Welcome everyone to 8.2b. This is going to be, well, we'll see how long this is. You'll know because you can look at it on a YouTube video and see how long it is, but hopefully it shouldn't be too bad. So remember that some of the stuff that we did at the end was talk about secants and cosecants over here. All right. And essentially one of the big things that we talked about is that these have asymptotes every pi units, and the period is 2 pi. Okay, so let's generalize that real quick. For y equals cosecant x, let's say a cosecant of bx. And we could do plus c, it doesn't really matter. A is the stretching factor, right? And the period is going to be 2 pi divided by b. This is, again, very, very similar to sine, because they're both 2 pi periodic functions. Okay, and the asymptotes here for cosecant, the first one is at 0, and then it's every half of a period. Okay, so remember a tangent was the first one is at half the period, and then they repeat every period. Well, here it repeats every half a period. Okay, so the asymptotes are going to be x equals essentially just half a period, which is going to be pi over b times k. So this should look a little familiar. This is actually the same as tangent. Okay, so the formula to find the asymptotes for cosecant is the same as, for cotangent. All right, and then similarly, right, if we look at y equals secant, I forgot the a again, a secant of bx, same stretching factor, same period, but the asymptotes for secant are going to be shifted over pi units, okay? So again, we can see this for cosecant, secant, just change that to cosecant. It's the same thing, just moved over, okay? So it's going to be at, the first one's going to be at a quarter of a period, and then they're going to repeat every half of a period again, all right? So it's going to be x equals a quarter of the period, which is going to be pi over 2b, plus every half of a period, which is just pi over b, times k. All right, and this should look very familiar because this right here, if I'm not mistaken, is exactly what it is for tangent. So there's only really 2 sets of equations you need to know for asymptotes. Secant and tangent have the same equation for asymptotes, and cosecant and cotangent have the same formula. So it's easy to remember which ones have the same formula. The cos have the same formula, and the non-cos have the same formula for asymptotes. So let's continue. I don't remember what example number we were on. Let's call it example 3. Okay, and same as example 2. Identify the stretching factor, period, and the asymptotes. And again, you don't have to graph these by hand on your homework. You can use a graphing calculator or Desmos, like I'm using Desmos right now. Okay, so part A is going to be g of x equals 2 secant of pi over 4x plus pi over 4. And again, we didn't really talk much about, what do you call them? Phase shifts. But the phase shift just affects everything else the same way that you'd expect the phase shift to work. So the stretching factor, again, is just that number in front of secant. It's going to be 2. The period is going to be 2 pi, because secant has the same period as cosine. Cosine's 2 pi. 2 pi divided by b, well, dividing by pi over 4 is the same as multiplying by the reciprocal. The period's going to be 8 here. Now the asymptotes are where it gets a little trickier, but again, we just look over here and incorporate the phase shift. So the asymptote is going to be x equals, remember this is a quarter of the period. Quarter of the period is just 2, plus a half of the period, which is 4, times k. So there's 1 at 2, and then every 4 after that is what the asymptote is. And that's all there is to it. Let's check our answers. All right, so we're graphing on this one 2 secant of pi divided by 4x plus pi over 4. All right, now we said The stretching factor is 2. Great. It goes down to 2, goes down to -2. Stretching factor of 2 checks out. We said the period was 8. Well, -5 and 3, that has a distance of 8. Likewise, -1 and 7, these x values also have a distance of 8, so we're good on the period. And the asymptotes, we said the first one, oh dear. We made a mistake. The first one is at 1. Not 2. Okay, so where did that mistake come from? Should be 1, and then every 4 after that. So 1, 5, 9, etc. So that's why we check our answers. Okay, so for secant, we said it was a quarter of the period, which was 2. And that's the part that's wrong. Give me 1 second here. Yes, all part of the plan. All part of the plan is a learning opportunity. First one's at pi/2. Oh, I forgot to deal with the phase shift. It's the right formula, but don't forget the phase shift, yes. All part of the demonstration. The phase shift, remember, is going to be this divided by that. C divided by B is 1, and it's to the right. Sorry, left. If we subtract, that makes it go to the right. If we add it, it makes it go to the left. So we incorporate our phase shift. And if you want to write on the formula like minus the phase shift or whatever, you can. I'm not going to, but you can. Don't forget the phase shift. Let this be a lesson to you. So it's going to be 1 plus 4k, which, when we checked our answer, is correct. All right. So let's do another problem. Let's do h of x equals, 6 cosecant of pi/3x plus pi. Again, we're going to have a phase shift here too. So let's not forget that. Stretching factor is that 6. The period is going to be 2 pi divided by b, which is 2 pi times 3 over pi. Period here is going to be 6, kind of similar. All right, the phase shift is going to be c divided by b, which is going to be pi divided by or multiplied by the reciprocal 3 over pi. The phase shift is 3. All right, and specifically since it's a plus, it's going to be 3 to the left. Or you can also just, instead of writing 3 to the left, you could also write -3. They're equivalent here. All right, and the asymptotes. Now we're dealing with cosecant. It's a different formula. For cosecant, it's just always half of the period. Half of the period times k. So x is going to be half of the period is 3 times k. But we're not going to forget our phase shift. Now here's something that's pretty interesting. So you might think, okay, we're moving 3 to the left, so we're going to have to subtract 3. And this is not wrong. This is a perfectly correct answer. But notice that 3k minus 3 is just the same as 3k. Right? Subtracting 3 just takes us to a different x asymptote. So these are equivalent. I'll take either answer, but this one looks a little nicer. Okay? So let's go back, check our answers. We have 6 times the cosecant of pi/3 times x plus pi. All right, and you might say, where's the graph? Well, the stretching factor is 6, so we should have to go in. And again, indeed, we can see the stretching factor is 6. All right, and now we said the, what else did we say? The period is 6. Does it repeat every 6? -1.5, 4.5, 10.5, 16.5. Yep, repeats every 6 units. The phase shift was 3 to the left. That is not. Is c divided by b. And the asymptotes are at 0. Yep, there's an asymptote at 0. 3, yep, there's an asymptote at 3. 6, yep, there's an asymptote at 6. 9, yep, asymptote at 9. All right. And I'm trying to figure out why the phase shift makes sense. 3 to the left. Oh, yeah. Because normally this would be the start of the graph right here with this asymptote. Good. All right, so the phase shift is also correct. All right, so good way to check your answer using graphing, and I recommend doing that on your homework as well. Okay, so let's do the next example. These are some really good ones. So example 4, again, one of the main things I expect from you from this section is to be able to recognize graphs. So that's what we're going to do here. Find an equation for the graphs. So we're going to do this how we did it the other day. I'm going to actually type in the graph on Desmos, and we're going to look at it together. So real quick, let me type in the first one, and then we will hide it for no cheating. And get this a little smaller. All right, so of course we do need to change the scale. All right, let's make the scale something like this. Like so, and let's say y-axis is going from -3 to 3 or something like that. So when we look at this graph now, what we're going to do is essentially talk about a couple things. So remember, first off, we have to decide whether this is secant or cosecant. And you don't have to memorize which one it's going to be. This is part A, by the way. There are some tricks that you can use to just figure it out, right? Recall that cosecant of x is 1 divided by sine, and secant of x is 1 divided by cosine. All right. Well, here we know which one it is because it's undefined at 0. Which one of these functions is undefined at 0? Well, when this function is equal to 0. So is sine of 0 equal to 0, or is cosine of 0 equal to 0? And again, we can tie everything together, go back to the unit circle. Sine is the x-coordinate. When the angle is 0, we're at this point, and this is the point 1, 0. So our trig function is 0 when y is 0, and y is 0 when sine is 0, or sine is y. So cosecant is our function we're using here. So we have to figure out some other things. So we're going to use cosecant here. We have to find the stretching factor. Stretching factor for secants and cosecants is super easy. As long as there's not a vertical shift, it's just whatever the y value is at all of these points. The y value is 1, so our stretching factor is just 1. Great. Let's find our period so we can figure out what b is. How often does it repeat? Well, we're over here at pi over 4 and 5 pi over 4. You could subtract those to find the period. It's going to be pi. Another way of saying, okay, our first asymptote is here, and our second asymptote is here, so the period's got to be pi. So remember that the period relates to your b value, but it does not equal the b value, right? Before we said that period is just 2 pi divided by b. Well, now I know the period, we need to find the b value. So we have pi equals 2 pi divided by b, and solve for b. Okay. Multiply both sides by b, you're going to get pi times b equals 2 pi, or just b equals 2 pi divided by pi, which is just 2. Okay, so that's going to be useful. And we already said there's not a phase shift because there doesn't need to be. If we used secant instead of cosecant, yeah, there'd be a phase shift. But we don't need one. There's no vertical translation either. So essentially, we have the whole function right here. We have y equals a, which is our stretching factor, which is 1. We don't need to write that. Equals, we said our function was cosecant. We said b was 2. We said there was no phase shift and no vertical shift. So this should be the equation of our function. And the big reveal, it was. Okay? Let's do another one. Let's do part B. All right, so we're gonna have to zoom out a little bit. Let's have y go from -8 to +8, something like that. So we got another function. And this does not have an asymptote at 0, but it looks a lot like cosecant. So we already immediately know that it's just going to be secant. All right. So over here we go and say, okay, we're going to be using secant here. And then again, we need to find the stretching factor. We need to find the period so that we can find b. Is there a phase shift? Is there a vertical translation? Well, notice that the minimum over here, the local minimum is 3. The local maximum is -3. So this immediately tells us our stretching factor. We just look at that y value. Okay, so our stretching factor is going to be 3. To find the period, we just see how long does it take till it repeats. Well, the distance between these two repeated parts of the graph is 2 pi. Period is 2 pi. I don't need to do on the math on that. I know that means b equals 1. There's no phase shift because we know that secant is an even function. And we are even right here. So we know there's no phase shift. All right, and there's no vertical shift because we go up to 3 and down to 3. These would not be symmetric, 3 and -3, if there were a vertical shift. So we have everything we need. Y just equals to 3 times secant of x. All right, and hopefully that's what I typed in. That is indeed what I typed in. Okay. Let's do a bit of a more difficult one. Wait, hold on. I'm spoiling it. All right, we're going to change the problem. I just spoiled it for you guys. We're changing the problem, all right? No cheating. I can't say it out loud. Otherwise, it's cheating. All right, so in this problem, I'm going to give you a step size of 1. Let's say y is going from, or y is fine. Let's say x is going from -5 to +5 or something like that. All right. So first off, we know this is not secant or cosecant. We just did secant and cosecant. And those look nothing like this. This is the shape of either tangent or cotangent. And tangent was the nice one. That's the one we know that tangent of 0 is 0. But cotangent of 0 is undefined, so we immediately know this is tangent. Right? Tangent of 0 equals 0, and cotangent of 0 is undefined. So we just look at our graph. Well, when x is equal to 0, y is equal to 0. So we know we're going to be using tangent right here. That kind of looks funny. It looks like Kodo or something. So we need to find the stretching factor. Stretching factor here is a little harder. Remember, to find the stretching factor, you have to look at how far do we go in a quarter of a period. Well, we don't even know the period yet. Let's find the period. Because tangent should go up 1 in a quarter of a period. The way you remember that is that tangent of pi over 4 is 1. So a quarter of the period should bring us to 1 if we have no stretching factor. What's our period here? How long does it take to repeat? Look at these points. Period here is 2. And remember that for tangent, the period is not 2 pi divided by b. For tangent, the period's pi divided by b. So if the period is 2, we get 2 equals pi divided by b, or b equals pi over 2. We're going to use that for later. So now that we know what the period is 2. When we go a quarter of the period is going to be at 1/2. We should normally go up 1 unit. But here, when we go up 1/2, we go up 3 units. Look at how far you go up after a quarter of a period. Period is 2. A quarter of that is 1/2. How far do we go up? Exactly 3. That's going to be our stretching factor. And again, there's no phase shift. There's no vertical shift here. Everything's very centered. So we're going to get y equals the stretching factor 3 times the tangent of b. We said b was pi over 2. Times x. Let's see if we got the right answer. Great. Checking whether you have the right answer is usually always kind of redundant in a math class. But or like during a math lecture. But I made that mistake earlier. So now you're never going to know whether we get the right answer or not. Keep you on your toes. So let's do more of these, all right? Because this is really the heart of the section. This is the kind of problem I want you to be able to do, all right? Are we on part D, I guess? Y equals 1/2 cotangent. Dang it, I did it again. I keep writing down the example. Spoiler. All right, we can't tell you guys. I can't tell you guys. We have a very mysterious function upcoming. All right. Let's use it. Oh, this one looks weird. This one looks super weird. All right. Wait, did I must have typed it in incorrectly. Hold on. We gotta. Yeah, I did type it in incorrectly. I was like, this looks like tangent. It should not look like tangent. I don't want a tangent one. There we go. This is better. Oh, don't look. And again, that actually looks like 1/x, but that's because I haven't finished my step size. So don't panic yet. Okay. And let's make the y-axis not so crazy. All right. So this is not tangent because tangent of 0 is 0. Here we have tangent of 0 being undefined. We've got an asymptote right there. All right. So we know it's not tangent. It's going to be cotangent. All right. So off the bat, we know we're dealing with cotangent of x. Now we just need to find some other things. We need to find the stretching factor. We need to find the period. Looking at asymptotes can help, but we don't really need that. And phase shift if we do. So we're going to have y equals something times cotangent of something, maybe plus something if there's a vertical shift. I don't think a lot of these have phase shifts and vertical shifts. Okay. So again, usually for tangent, it's easiest to start for the period. Yeah, and the period's 2 pi. Exactly. The asymptote. For cosecant and secant, the asymptote's half the period, but for tangent and cotangent, the asymptote's the whole period. Or you could look at these points. How far is pi from 3 pi? And the answer is 2 pi. Very good. So the period is 2 pi. So if this were sine, cosine, cosecant, secant, that would mean that b is 1. But it's not. The period for tangent and cotangent is always pi divided by b. So 2 pi is pi divided by b, or 2 pi b equals pi divided by 2 pi. You're going to get b is pi divided by 2 pi, which is just 1/2. So the period is 2 pi, but b is going to be 1/2. All right. And now cotangent is very similar to tangent, that when you are 1/4 of the period away from 0, you should be at 1. But here, 1/4 of the period, we're at 1/4. Here, when we move 1/4 of the period this way, we're also roughly at 1/4, if I can find the 1/4 of the period. Okay. So we are 1/4 as tall as we think we should be. We should be at 1, but we are actually at 1/4. All right. So our stretching factor is 1/4. So you have 1/4 cotangent of 1/2 x. Hopefully that's what I typed in. Well, it's written a little differently, but these are the same, yes. X over 2 is the same as 1/2 x. All right, so that's essentially those problems. So let's do the last example. All right. And I'm not going to write the last example over here. If you want to include the example in your notes, then you can just, if you want to include the last example in your notes, you can just pause the video right now. But we're going to be using this. So we have this function. Y is equal to the tangent of pi over 4 times t. And that marks the distance of, I got a couple typos here. And that marks the distance of a moving light beam from a police car across a wall, with t is the time in seconds and y is the distance in feet from a point on the wall directly across from the car. So this is super confusing. This sounds super confusing. Let me draw you guys a picture. I'm a very good artist. Okay, so we have a wall right here. And that's our wall. Then over here we got this nice little police car. And on the police car, it's got, you know, a door right here or something. It's got a windshield, it's got a window, something like that. On the top of the police car, we got these super obnoxious lights. And essentially what this function represents is, right, the light, maybe it's shining right here. Maybe the light is shining in this direction. Maybe the light is shining in this direction. Maybe the light's shining in this direction. Who knows what direction the light is? But the function is always, what is the distance when we are at a direction x? Or is x direction? No, t is time. Okay, so our function is y equals 5 tangent of pi over 4t. So as a function of time, it shows us how far the light is from the wall. And this is why tangent's a good choice here, because assuming that light travels indefinitely, which it doesn't, but assuming that it did and the wall goes on infinitely, which it doesn't, we get some asymptotic behavior. Because when this is almost at 90 degrees, this is going to go so far. Again, assuming that everything goes infinitely here, you know, it's a math problem, all right? So part A is going to be find and interpret the stretching factor and the period. So finding these are not hard here. All of you can find these. The more tricky part here is going to be interpreting them in context of the equation. So let's start with the period. Well, let's do both. Period is usually a little easier to start with. The period is always going to be pi divided by b, right? And pi divided by b is pi times its reciprocal, which is 4. So remember, in a graph, the period is just how long it takes until it repeats. Well, it's the same here for this police car. How long does it take until this distance repeats? Well, the distance has to do with the lights. So essentially, this is how long does it take for the entire light to turn around, and it's going to take, well, what is t? T is the time in seconds. So that tells us that it takes 4 seconds for the light to go all around. Okay? And wait, is the light shining in 2 directions? Yeah, so I guess technically the light to go halfway around, right? Because the police car lights shine both ways. I'm pretty sure they do anyway. Anyway, I'll be lenient on interpretation of stuff like that if you don't know police car lights as well as I do. Or I don't know them very well. Anyway, that's the point. Stretching factor is the number in front of the tangent, which is 5. So, oh, also this graph is a little wrong. It says, y is the distance in feet from a point on the wall directly across. So these are not actually our y's here. The y is the distance from this point. So here y would be 0. And then we'll have a y right here is how far it is from here. So it's the same idea. It just changes what 0 is. Okay, and then, you know, at this time over here, y would be this whole distance. Y would be this whole distance. Y is going to be a distance from this point on the wall. All right, and again, this goes on forever, a never-ending wall. the Great Wall of trigonometry, if you will. Okay, so essentially what this is saying is after a quarter of the period, normally without a stretching factor, tangent goes 1. Well, this tells us that after a quarter of the period is 1, tells us that after 1 second, y is going to be 5. Well, what is y? Y is the distance in feet from that point. So after 1 second, the light has moved 5 feet. All right, and there's a couple different ways to answer this. Just answer it in terms of the problem, and you'll get credit. All right. Oh dear. We're going on to part B, but we're going to miss our picture. Part B, oh, that's fine anyway, is graph on the interval from 0 to 5. And again, our period is 4, so we should see part of our period. And again, I'm not going to make you graph this by hand. Graphing by hand was 8.1. 8.2 will not require graphing by hand. So you can use a calculator or a graphing utility like Desmos. So you get 5 times tangent of pi divided by 4t. Oh, caps lock is on. And it wants us to look at this from the interval from 0 to 5. All right, y-axis might need to change a little bit. Let's make it even more. Like this. So let's see if this works as we'd expect it to work. Let's look back to our picture real quick, right? We expect that at the beginning, at time equals 0, we are right here. We're starting by shining directly across. So this is 0, y is 0, x is 0, or time is 0. And then as time goes on, we should get farther and farther away until half of the period, when we should appear again super far this way and go back to 0. After a period, we should return to 0. Does this make sense? Well, yeah, we started off at 0. Okay, and we said after a quarter of our period, we should be at 5, which we are, 5 feet. And then the further and further it rotates away from the wall, the faster and faster the light starts moving until at half the period, when the lights are now shining parallel to the wall, the light is infinitely far away from the wall. Okay? And then it appears now on the left side. This is your left. Really, really far away. And it goes. And after a period, our period we said was 4. After a period, it's in that spot directly across from the police car again. So this graph makes sense with how we should conceptually understand this phenomenon in real life. Okay, so that was part B. Part C is evaluate. Oh, we kind of already did this. Evaluate f of 1 and interpret. Kind of jumped the gun. All right. Oh, no. This is a little, no, we did jump the gun. All right, well, if we plug in the formula, right, f of 1 is equal to 5 times the tangent of pi over 4 times t, which is 1 here, which again is 5 tangent of pi over 4. Tangent of pi over 4 is 1, so it's 5. And again, this is just, part C is exactly the same answer as part A over here. After 1 second, the lights moved 5 feet, so see part A. Feel free to do this on your quiz or your homework if that happens. All right, but we already answered it. All right, after 1 second, we're 5 feet away from the spot directly across the car on the wall. All right, and that's all there is to this section, okay? So there's essentially 3 things you need to be able to do in this section. You need to be able to recognize these 4 trig functions. You need to find the stretching factor, period, and asymptotes. You need to be able to recognize you need to be able to find the equation of a graph given the graph. Okay, and that's what's going to be on your quiz for this week. If you have any questions, send me an email, and thanks for watching.